All right, Algebra 1B students. Welcome to part 1 of lesson 11.1. We are starting chapter 11 today. And we are going to start looking at what are called rational expressions. Now, I hope you remember from Algebra 1A that rational numbers means fractions. Just means fractions. All numbers written as fractions. So rational expressions are just expressions that are written as fractions, that start out as fractions. So a rational expression is given right here. It's just a polynomial over a polynomial. Now, reminder, polynomials are things like 3x plus 2, or x squared minus 2x plus 4. So polynomials involve x's, maybe y's, maybe numbers, r's, z's, sometimes exponents. So if you see two polynomials like this in a fraction, that is called a rational expression. Okay? Make sure you get some examples of rational expressions in your notes so that you know what you are looking for when it comes time to solving problems. Now, the simplified form of a rational expression is just like simplifying fractions. Just like simplifying fractions with numbers. Common factors is what we are looking for. We will cancel them out of the top and bottom. So we're looking to cancel common factors from the top and the bottom. Okay? And once we cancel them, they are gone. They will disappear just like they do when we simplify fractions. One more thing we need to add to our notes before we move on to see what kind of problems we will look at today. We need to understand what an excluded value is. I hope that you understand that we cannot divide things by 0. 2 divided by 0 is not allowed. So we can't do something like that, which means the denominator of our fraction is never allowed to be 0. So you will be asked in your practice problems to state any what are called excluded values. State any excluded values, which means values of x or numbers that we could put in for x that would make the bottom of the fraction, make the denominator 0. Okay, those are not allowed because the denominator of our fraction cannot be 0. Not allowed to be 0. So we will look for those values of x by basically setting the bottom of the fraction equal to x and solving. Okay? So here's what our practice problems are going to look like today. They're asking for the simplified form of x minus 1 over 5x minus 5, and to state any excluded values. What we are going to do as our step 1 is factor the top and bottom of our fraction. Now in this particular example, the top is already as factored as it can get. X and 1 do not have anything in common, but in the denominator, 5x minus 5 can be factored. I could pull a 5 out of both of those because a 5 is being multiplied in both of those pieces. So when I factor the bottom of this fraction, like I said, the top is already factored. I can't do anything there. The bottom of this fraction, if I pull out a 5, I'm basically doing the reverse of the distributive property. So it is 5 times, and what I'm left with in the first one is an x. And what I'm left with in the second term, well, I divided 5 by 5. Essentially, I'm dividing out a 5 and putting it in front. So here, 5 divided by 5 is just 1. So I factored out x minus 1, and the bottom is now 5 times x minus 1. And I could confirm that if I redistribute that 5 to x and the minus 1, I do return to 5x minus 5, so that's good. And then step 2, when we're solving these things, is to cancel common factors in the top and the bottom. I'll just say cancel common stuff. So what that means is on the top of this fraction, of this rational expression, I see x minus 1. I also see x minus 1 in the bottom of the fraction, so I'm going to cancel it in the top, cancel it in the bottom. Okay? What I am left with on the bottom is just a 5. I'm really left with nothing on the top, but that doesn't mean it's 0. I'm essentially, once again, dividing out an x minus 1. So when I divide out everything on the top, I'm left with a 1. Okay? So when you cancel and nothing is left, or when you pull something out or factor something out and nothing is left, please put a 1, don't put a 0. That will be the wrong answer. Now, 1/5 is a fraction in simplest form, so I am done with the simplifying. Okay, the simplest form, or the simplified form here, is 1/5. But I do have to worry about these excluded values. I need to state any excluded values. So in my final step, step 3, set the denominator, let's put denom, to 0 and solve. And this will find me my excluded values. The bottom of my original fraction was 5x minus 5. If I set that equal to 0 and I solve for x, I will add 5 to both sides and get 5x equals 5, which means x is equal to 1. So my final answer for this problem is that the simplified form is 1/5 with an excluded value of x equals 1. Or, the way we say excluded, we just put a slash through the equal sign, which means x is not allowed to be 0. Or sorry, excuse me, x is not allowed to be 1. X is not allowed to be 1. Not equal to. We slash through the equal sign to say x cannot be 1. Okay? My simplified form is 1/5, but x cannot be 1 in my original expression. Now I'd like you to take a minute, try these two, got it number 1 here, just these two expressions. 18d squared over 4d plus 8, 2n minus 3 over 6n minus 9. Factor out what you can, cancel what you can, and find my excluded values, please. Pause the video, take a look at those, then come on back and I'll show you what we should get. Alright, in letter B, the bottom should turn into 4 times d plus 2. The top is still 18d squared. I can cancel the 18 with the 4 and make it 2 and 9. So my simplified form is 9d squared over 4d plus 4. If I redistribute that 2 back to the d and the 2, 4d plus 4. So excuse me, 2d plus 4. 2d plus 4. And then my excluded values, if I set 4d plus 8 equal to 0 and subtract 8 from both sides, 4d equals negative 8, d equals negative 2. So d is not allowed to equal negative 2, but my simplified form is 9d squared over 2d plus 4. And over here, the top becomes just 2n minus 3. I cannot factor anything out of both of those. 2 and 3 have no common factors. 6 and 9 do, however. I can do 3 and, oh, look at that, 2n minus 3. So now I see a 2n minus 3 on the top and the bottom. My simplified form is 1/3. But I have an excluded value, 6n minus 9 equals 0. Add 9 to both sides. 6n equals 9, n equals 1.5. So n cannot equal 1.5, but my simplified form is 1/3. What I want you to realize here is sometimes your simplified form is nice and simple, 1/3. Sometimes it's not. 9d squared over 2d plus 4 is not that simple. But That is the most simplified form. Okay? Now we also need to be aware that sometimes the bottom or top of our rational expression will require us to factor a quadratic. That's why we practiced that in class today. So in this case, when they want the simplified form of 3x minus 6 over x squared plus x minus 6, and I factored the top, that's relatively easy. Just take a 3 out of each piece, take a 3 out of here and out of there, and I get x minus 2. So I took a 3 out, and I have x minus 2. Now, the bottom, I need to factor that quadratic. So I'm looking for two numbers that multiply to be negative 6 and have a difference of positive 1. Positive 1. Multiply to be negative 6. 3 and 2, I want a positive 1, so I will make the 3 positive. X plus 3, x minus 2. Okay? So now I've factored the bottom. I've factored this quadratic to be x plus 3x minus 2. I shouldn't put that bar there because it looks like another fraction. But now I can cancel out because I have a common factor on the top of x minus 2 and the bottom of x minus 2. So I will cancel that out. And I'm left with 3 over x plus 3. There's my simplified form. 3 over x plus 3. However, I have two excluded values here, because if I set x squared plus x minus 6 equal to 0, this is just what we were doing in our introduction problems today. Again, this is x minus x plus 3, x minus 2 equals 0. I'm going to solve this by factoring. Find my two x values that make it 0 by factoring. X plus 3, x minus 2. So x can equal negative 3 or x equal negative 2. Which means for my excluded values, x cannot equal negative 3 and x cannot equal a positive 2 here. Excuse me, this should be a positive 2. So I have my simplified form there in red that I got when I canceled those x minus 2 factors. And I have my excluded values here in blue. X is not allowed to be negative 3, and it's not allowed to be positive 2, because those two are my solutions when I set the denominator equal to 0. Okay. Couple for you to try here. These two problems, you have to factor the bottom in A, factor the quadratic, and the top in letter B. And make sure that you cancel something out and get a more simplified form, and then state your excluded values. There are two excluded values in A and one in letter B. So pause the video, take a look at those, then come on back, and I will show you what we should get. Okay, in letter A, our top factors to this, bottom factors to plus 2 minus 4. The minus 4's cancel, and I have 2 over x plus 2. But when we solve the quadratic on the bottom equal to 0 by factoring, I have excluded values of negative 2 and positive 4. Letter B, the top factors into a minus 1, a minus 2. The bottom factors into 3 times a minus 1. I see an a minus 1 there, and an a minus 1 there. My simplified form, a minus 2 over 3, but I have excluded values of a, let's see, cannot be 1. If you have questions about factoring and canceling, please make sure to ask me in class tomorrow. Otherwise, that's all I have for you right now. Have a wonderful night.